Okay, so this is again an example of a 2D inelastic collision. So we have the blue car traveling east at 20 and the red car is traveling north at 10. So actually, this one's actually relatively simple because the total momentum before is equal to the total momentum after, as always, right? But really, all you've got is these two vector momentums that have to equal this vector momentum, right? So how do you find this vector momentum? You simply add those two together. You don't have to do components because it's north and east, so it's already sort of componentized, if you want to make up a word like that. So really, all I got to do is, right, I've got this one and this one. This is my momentum blue, this is my momentum red, and so this is my momentum, how about I call it T for total? Right? So what I did here was I figured out what those momentums were, 1,000 times 10, and 1,000 times 20, and I get 1,000, or 10,000 and 20,000. And so now I'm simply going to find the total momentum at the end. So PT squared is going to be equal to the red momentum squared plus the blue momentum squared. Okay, so that's going to be the square root of 10,000 squared plus 20,000 squared. I get 22,360. And that's going to be kilogram meters per second. Right? So that's the total momentum. We need to find the combined velocity after the collision. So I guess the first thing you need to find out is the total mass after. Right? So that's going to be, no, they're each 1,000, aren't they? Yeah, not the, no, we're adding the masses together, right? So that's going to be 1,000 plus 1,000, 2,000 kilograms. And so momentum total is mass total times velocity total. So this 22,360 is going to equal 2,000 times the total velocity. Divide both sides by 2,000. I get 11.2 meters per second. Does that seem reasonable? What were the initial velocities? 10 and 20, right? Well, it's bigger, so yeah. And actually, if you look here, you can both see that the velocity right there, 11.2 in the little animation. Yeah. Am I done?
Oh, direction.
It's a simple mark, right? It's the same thing over and over again, though. Theta equals inverse tan, opposite over adjacent. So in this case here, that's the red one is the opposite. Red is 10,000, so it's going to be 10,000 over 20,000. So that's going to be east 26.6, let's say 27. East 27 north. That's actually a pretty easy question. What makes it easy? You'd have to do components. Yeah. What could I do to make it harder? How would I do that? What would have to change in the question so that you would have to break it into components? Yeah, but not specifically what part of the velocity? The directions, right? Right now they're east and north. So if I said that one car was traveling at north 30 east and the other one was at south 10 west, right? How would you do that then? You'd have to add the components together, find the total, and then do the same thing.